The previous topic dealt with raster databases. The other data model used by geographic information systems is called the vector model. In this model, database objects are described by the coordinates of their vertices, hence the name vector. Among the databases of this model supported by ArcGIS are the CAD files produced by AutoCAD and Autodesk Civil 3D, both in DWG and DXF versions, as well as the CAD files produced by MicroStation, easily identified by their DGN extension. These files can be read directly into ArcGIS, but they cannot be edited, that is, their contents can be symbolized, viewed and analyzed, but cannot be changed. ArcGIS also has tools that allow you to export your databases to some versions of these formats. We'll look at some of these tools in the third part of this topic. In addition to CAD files, ArcGIS supports other vector databases, particularly enterprise geodatabases, mobile geodatabases, file geodatabases, and shapefiles. Examples of enterprise databases include Oracle, Microsoft SQL Server, IBM DB2, and PostgreSQL. From a conceptual point of view, we could think of a shapefile as a folder, inside which we store a series of documents that share a given geometric typology. In the case of ArcGIS, these documents can be represented by geometries of the point, line, or polygon types. However, each shapefile can only contain one of these types of geometry. In other words, a shapefile can only store points or lines or polygons. In contrast, we could think of geodatabases as cabinets, with several drawers, inside which we can store several folders, which in turn store a series of documents that share a given geometry type. Each of its drawers is called a feature dataset, and each of its folders is called a feature class. As you can see from the diagram, each geodatabase can contain several datasets, and within each dataset, we can store several feature classes. Each feature class will correspond to a single type of geometry, that is, a feature class will be able to record objects of the type point, line, or polygon. Still, it will not be able to mix different geometries, as is the case with shapefiles. However, as each dataset can store several feature classes, the same geodatabase can store different geometries. Despite this conceptual framework, not all feature classes necessarily need to be stored inside datasets. If we assume that a simple box can replace the cabinet that represents our geodatabase, we can easily see that it is possible to store several files, that is, several feature classes, directly in the box, without drawers, which is like saying directly in the geodatabase, without them being inside datasets. We'll look at this aspect in practice later, in the second part of this topic. Another important difference between geodatabases and shapefiles concerns the type of objects that each can store. Geodatabases can store points, multipoints, lines, polygons, 3D objects, annotations, dimensions, multipatches, and networks. Dimensions, annotations, and 3D objects cannot be stored in shapefiles. Another aspect differentiating them is the ability to create and edit geometric topologies and networks in geodatabases. With shapefiles, the topology can only be defined on the maps, not in the shapefile itself, which means that you have to create the topology every time you need to create a new map using topology. In this image, you can see the way the Arc catalog symbolizes geodatabases and shapefiles, and in some way makes a conceptual comparison between a dataset and a folder storing a set of shapefiles. As far as geodatabases are concerned, ArcGIS Pro supports 3 different types. These are enterprise geodatabases, mobile geodatabases, and file geodatabases. Personal geodatabases, used in ArcMap versions, are no longer supported in the Pro version because they are 32-bit databases. The group of enterprise geodatabases includes the databases I mentioned earlier: Oracle, Microsoft SQL Server, IBM DB2, and PostgreSQL. In practical terms, Enterprise geodatabases are made up of a set of different types of geographic data, kept as tables in a relational database. Mobile geodatabases are a collection of varied geographic data sets contained in a relational database. A file geodatabase consists of a set of files contained in a system folder. About the number of users each supports, enterprise databases support several users simultaneously, both in read and write mode, that is, accessing the data just to view and analyze it, but also in edit mode, creating new records, altering or deleting existing records. Mobile geodatabases and file geodatabases, on the other hand, although they support several users in read mode, only support one user in edit mode. As for storage formats, enterprise databases have their own formats. Mobile geodatabases are SQLite databases stored in a single file. In file geodatabases, each dataset is a separate file, and all the datasets stored in the same geodatabase are contained in a single system folder. The following images show a succession of Arc Catalog and Windows Explorer windows, summarizing the creation of a file geodatabase, a mobile geodatabase, and a shapefile. In the first image you can see, side by side, the folder inside which the databases will be created. After creation, you can see the file geodatabase on the left, with the GDB extension in the Arc Catalog, and the system folder on the right, seen in Windows Explorer, inside which a series of files have been created that will manage the geographic data that the database will store. When you create a dataset, and a feature class, you realize that the number of files inside the folder corresponding to the file geodatabase has increased. The mobile geodatabase corresponds to a single file with the extension geodatabase. Any other files that may be created only exist while the geodatabase is being edited, and are deleted as soon as the project is closed. A shapefile, seen by Catalog as an entity in itself, is made up of a set of files that share the same name and different extensions. Each of these files contributes a specific role to the shapefile as a whole. Some of these files are essential, as is the case with files with the extensions SHP, DBF, and SHX. Returning to our comparative table and the storage volume of each type of database, it can be seen that enterprise databases are limited by their particular characteristics. Mobile geodatabases are limited to 2 terabytes. File geodatabases are limited to 1 terabyte per dataset, although this figure can be increased for large image sets. However, as each file geodatabase can contain several datasets, a file geodatabase can store a large volume of information. Versioning, that is the ability to create versions of your content throughout successive editing operations, is truly supported by enterprise databases and not supported by mobile and file geodatabases. About the platforms on which they are applicable, all three types allow transfer between different systems. Security is perhaps the Achilles heel of mobile and file geodatabases. They have no security management tools, and all the security they can provide comes from the tools of the operating system on which they are installed. The comparative table used in the previous slides can be found in the ArcGIS documentation using the term Types of Geodatabases for ArcGIS Pro. This table is accompanied by a set of complementary information describing the aspects to which we have referred, and other equally interesting aspects. That's all for now. See you soon.